वेलकम टू माय न्यू यूट्यूब चैनल भाटिया क्लासेस। जैसे कि आप लोगों को पता है कि लॉकडाउन का समय चल रहा है, के लिए क्या लेके आया हूँ 10th क्लास का मैथ्स का फर्स्ट चैप्टर रेशनल नंबर्स। जैसा कि आपको पता है 10th क्लास बोर्ड की क्लास होती है, आप लोग इसे मिस नहीं कर सकते, आप लोग मार्क्स भी लेना चाहते हैं, तो मैं विदाउट वेस्टिंग एनी टाइम आई विल स्टार्ट विद द रेशनल नंबर्स। आप सभी 10th क्लास में पढ़ते हैं तो आप सभी को पता तो होगा कि रेशनल नंबर्स क्या होते हैं। फिर भी मैं इंट्रोडक्शन के लिए आपको बता देता हूं व्हाट आर रेशनल नंबर्स। द नंबर्स व्हिच आर इन p/q form, these numbers are known as rational numbers. For example, √4 is equal to 2, √9 is equal to 3, √16 is equal to 4. All these are rational numbers, but √5 is an irrational number. Now you will ask how? √5 एक irrational number कैसे है? तो इसके बारे में मैं आपको नेक्स्ट क्लास में बताऊंगा। अभी मैं इस टॉपिक को इरेज करना चाहता हूं यहां से, और फर्दर जो प्रॉब्लम्स हैं मैं उन्हें यहां पर एक्सप्लेन करूंगा आप लोगों के लिए, जो आपकी एनसीईआरटी 1.1 में है। Exercise 1.1. This exercise is based upon Euclid division. Sum number first 135, 225. Here I will show you how to solve this. Keeping 225 inside, start dividing it by 135. 135 is to 135. By subtracting, you got 90. Here 90 can't be divided by 135, so you will take 135 as a divisor. 135. 91 is to 90. Remainder is 45. Again repeat that step. Bring 90 as a divisor. 90. 45 to the 90. It got divided fully. The last dividend. Here you find 45. That is known as HCF of these numbers. So here you see that by Euclid division you can find out HCF of the two numbers. You can find out the HCF of three numbers also, but that is not in the our syllabus. Now I will explain you the other problem of this. Second problem of the NCERT book 196,38220. This problem is different from the first one. I will show you. Same procedure as you do in the earlier classes, simple division method. 196 is to 196. By subtracting you got 186. Putting 2. Now you will see that 1862 can be divided by 196, because 1862 is greater than 196. You will multiply it by 9. Here I got 1764. By subtracting you got 98. Now taking 0. Again it will be multiplied by 5. You got 980. Cross. What will you see that? 196 completely divides 38220. Therefore, this is known as the HCF. If the number can be divided completely, then you have to divide it completely first. Next. I will show the third sum first. Third sum based on army contingent. In this example, 32 members of band are to be followed by 616 members of the army contingent. I will show you by the simple statements. Total band members is equal to 32. Total army persons is equal to 616. If you are keeping your book with yourself, then you can see in the statement a word maximum. Maximum means you have to find out the HCF of these two numbers. I will show this by same Euclid division procedure. 32 is to 1, 32. By subtracting 29, taking 6, multiplied by 9, you got 288. So by subtracting you got 8. Now 8 is less than 32. Take it here. 8 4 is to 32. 8. This is the HCF. Therefore, maximum number of lanes is equal to 8. Now you will ask me when to find LCM. That will be explained in the next exercise. I have explained you sum number 1 and 3. There are 3 remaining. 2, 4, 5. These 3 sums are based upon Euclid division lemma. Hope you know that what is lemma. Lemma is just like theorem but based on algorithm. Here are some steps you have to follow in these sums. I will explain you. As written in your book, in second sum, odd numbers are formed by 6k plus 1, 6k plus 3, 6k plus 5. First, what are odd numbers? Which are not divisible by 2. For example, 1, 3, 5. These are odd numbers. Now, let's see. These numbers have to be compared with A equal to PQ plus R. This is division algorithm, or you can say division formula. Now, I will show you how to tackle this sum. Compare it. Hope you are watching this clearly. V is equal to 6 and R varies from 0 to B. It means R will have 6 values. How? Let me show you. This sign means R is equal to 0 and greater than 0. I will show you how to write it. R will equal to 0, 1, 2, 3, 4, 5. R is starting from 0 and ending at 5. But calculate these numbers. These are 6. Next. Now I have to use the values of R. How to use this? Let me show you. When R is equal to 0, A is equal to 6Q plus 0. A is equal to 6Q plus 0. 6Q is equal to 2 multiply 3Q. As this number is multiplied by 2, this is even number. When R is equal to 1, A is equal to 6Q plus 1. Now 1 is added to an even number, therefore it is an odd number. Next, R is equal to 2. Follow these steps to the number 5. A is equal to 6Q plus 2. Even plus even, that is even. R is equal to 3. A is equal to 6Q plus 3. Or similarly, 6Q plus 4. Even. 6Q plus 5. Or. Now you can see that 1 or 3 or 5 or. So our problem is solved. 6Q plus 1, 6Q plus 3, 6Q plus 5, that these are odd numbers. Let me show you with the next one. Sum number 4. Square of any number in form of 3n, 3n plus 1. Here from the statement you can see that b is equal to 3 and r will vary from 0 to 3. Therefore r is equal to 0, 1, 2. This is the main thing you have to follow in this sum. When r is equal to 0, a is equal to 3q, then scaling on both sides, a square 3q square, a square 3 multiply 3q square, 3q square, 3 into m, where 3q square is equal to m. M is any integer. Now, when r is equal to, by mistake I have written it to r is equal to 1. Here you will have to apply the identity. A is equal to 3q plus 1. Now scaling a square 3q plus 1 square. Apply the identity a square plus 2ab plus b square. 3q square plus 2, 3q multiply 1 square. 3q is 9q square, 6q plus 1. take a common 3. Here you got 3 cube square plus 2 cube plus 1. Similarly, as you have done in the first step, write it m 3m plus 1, where 3 cube square plus 2 cube is equal to m, and m is similarly is an integer. You got that? Square of any positive integer is in the form of 3m and 3m plus 1. This is the first exercise. I have left the last sum for you. You have to solve that sum by your own. Next class will be uploaded shortly. Hope you have liked this because this is my first lecture. Thank you. Hello friends, welcome again into my YouTube channel Bhatia Classes. Today we will continue 1.2 exercise of the rational numbers chapter 1 of the NCERT book. Without wasting any time, I will go to my topic. This exercise is based upon LCM and HCF on the prime factorization. First sum, you have to find out the prime factors of 140. 140 can be divided by 2, 70, then again by 2, 35, again by 5, 7, then 1. You got 140 is equal to 2 raised to power 2 multiply 5 multiply 7. These are the prime factors of 140. I will do the one more sum. Prime factors of 3825. This number can be divided by 3 and 5, but this is the rule. You have to take the small number. Divided by 3, 1, 2, 7, 5, again by 3, you got 4 to 5, then by 5, you got 85, again by 5, 17, 17 is a prime number, so it will be divided by only 17, 1, therefore the prime factors of 3825 is equal to 3 square, 5 square multiply 17. The next parts will be solved by you next one. In this topic, now you will learn how to find the LCM and HCF of the different quantities by prime factorization. I will take this example, 6, 72, 120. 6 divided by 2, 3, 1. 72 divided by 2, 36, 2, 18, 2, 9, then by 3, 1. 120 by 2, 60, 60 by 2, 30, 30 by 2, 15, then 15 by 3, 5, and 5. 6 is equal to 2 multiply 3. 72 is equal to 2 raised to power 3 multiply 3 raised to power 2. 120 is equal to 2 raised to power 3 and 3 raised to power 1, 5 raised to power 1. Firstly HCF and then LCM. Let's start with HCF. 2 is common in all three. and 3 is also common. Therefore 2 multiply 3, HCF is 6. I have taken 2 one time, 3 also one time, because the common factor is 1, not 3, not 2. Next, LCM. In LCM, you will take the highest quantity of common factor, that is 2 raised to power 3. Highest power of 3, 3 raised to power 2, and also 5. 2 raised to power 3, 8. 3 raised to power 2, 9. Multiply 5. 8 9 is 72, 72 5 the 360. This is the LCM of 6, 72 and 120. Similarly, you can find the other sums. Now I will go to the fourth sum. This is based upon the formula LCM multiply HCF is equal to product of two numbers. The given sum is that HCF of 306 and 657 is equal to 9. You have to find out the LCM. You can see that HCF is given as 9 and the numbers are 306 and 657. Now apply this formula. 306 multiply 657 is equal to 9 multiply LCM. Take 9 as denominator of 306 multiply 657 is equal to LCM. Cut 306 by 9, you will got 34. Therefore, by multiplying 34 and 657, you will got the LCM as 22,338. This is the answer of fourth sum. Next. Sum number 5. 6 raised to power can and with 0. Most of the teachers avoid to do this sum, but I will tell you how to do this sum. 6 raised to power can end with 0. We will take a simple example as like 10. The prime factors of 10 are 2 and 5. 100 you can break. 20 multiply 5. Now break 20. 2 multiply 5 multiply 5. Here you can see 2 and 5. Always the prime factors of a number ending with 0. Now multiply 2 multiply 5 multiply 5. Here you can see the number ending with 0 having prime factors as 2 and 5. Now we will see our number 6 raised to power n, which is equal to 2 multiply 3 to the power n. 6 raised to power n contain 2 raised to power n and 3 raised to power n. But this not containing 5 as its factor, therefore this number can't end with 0. 5 is not the factor of 6 raised to power n. Therefore it can't be end with 0. Next part. Now the last sum of this exercise, 7 sum. Sonia take is equal to 18 minutes and Ravi take is equal to 12 minutes to complete their rounds. Let me show you by the circle. Suppose Sonia starts from here and completes one round in 18 minutes. But Ravi completes his full revolution in 12 minutes. Then how to find when they will meet again? This can be explained by LCM, or you have to find the LCM of these two numbers. 18 is equal to 2 multiply 3 multiply 3. You can do it your own. 12 is equal to 2 multiply 3. Now I will find the LCM. Here you can see 2 is 2 times, 3 will be also 2 times. 4 multiplying 9 is equal to 36 minutes. After 36 minutes, now let's start exercise 1.3. As I have told you that root 5 is an irrational number. In exercise 1.1. In this exercise, I will explain you how root 5 is an irrational number. This is an boring sum. So, please concentrate. Let root 5 is equal to a by b, where a and b are co-prime numbers. Co-prime means this cannot be divided on, or these cannot be the factors of same number. By cross multiplying, you will get root 5b is equal to a. I will give this equation 1. So every one of you know that root can only be removed by scaling. Therefore, scaling on both sides. Root 5b square is equal to a square. 5b square is equal to a square. Now you can clearly see a square is multiple of 5. We will write this line. A square is multiple of 5. Therefore, it is understood a is also multiple of 5. Now I will let a is equal to 5c and will put the value of a in the equation 1 using value of a in equation 1. 5p square is equal to 5c square. Here you can see that I have put the value of a here. 25p square, sorry, by mistakenly I have written 25 here. 5b square equal to 25c square. Let's go to the other side. I will rewrite this. 5b square equal to 25c square. 5 b square equal to 5c square. The same process is following here. You can see b square is also multiple of 5. B square is multiple of 5. Similarly, B is also multiple of 5. We have taken that root 5 is equal to A by B, and this is in the form of A by, therefore it is a rational number, and we have also let A and B are co-prime. But here you can see B is multiple of 5, A is multiple of 5. This contradicts our assumption. Therefore, it contradicts our assumption such that root 5 is a rational number. So we have proved that root 5 is an irrational number. This is the sum typically based upon irrational number. Now I will tell you the other example. Second example, prove that 3 plus 2 root 5 is an irrational number. Let 3 plus 2 root 5 is equal to A by B. Take 3 on the other side of equal, A by B minus 3 2 root 5 is equal to, by taking LCM, B A minus 3B root 5 is equal to A minus 3B by 2B. Here you can see that A minus 3B by 2B is in P by Q form. This quantity is in P by Q form. Therefore, since A minus 3B by 2B is a rational number, therefore root 5 is also rational. Also rational number. But you have already done root 5 is a irrational number. But as we know, root 5 is an irrational number. Therefore, it contradicts our assumption such that 3 plus 2 root 5 is rational number. Therefore, it is proved that 3 plus 2 root 5 is an irrational number. You can write here the same thing as you have written in first sum, where A and B are co-prime numbers. Similarly, you can also prove that root 2, root 3, or root 7 also are irrational numbers. By same method as root 5. And also the other sum given in your exercise, 6 plus 2 root 3, 7 plus 2 root 5. These sums can also be find like 3 plus 2 root 5. And one interesting thing, these sums are important either you are studying in HBSE or CBSE. Now let's start the next exercise. Exercise 1.4. Based upon terminating or non-terminating. You have studied in class 9 that repeating words or non-repeating words. Let me show you with an example. I am writing here 17 by 8. Take the LCM or make the prime factors of denominator by 2, again 2, you got 17 divided by 2 raised to power 3. If you got 2 or 5, then this number is terminating. But if you got other than 2 or 5, for example, if you got 2 multiply 3 in the denominator, this number is except 2 and 5, therefore these numbers are non-terminating and these numbers are terminating. Let me show you with another example. (29 by 3, 4, 3). Let's take the LCM of 3, 4, 3. 7. 49. 7, 7, 7. 29 by 7 raised to power 3. Here you can see. You have got 7. Therefore, this number is non-terminating. Now I will tell you how to reduce terminating numbers in P by cube form. 15 by 1600 and also 6 by 50. We will do these two sums. Let me start. If you can cut, then firstly cut these numbers. 5 is to 3. And by cutting 1600 into 5, you got 320. Take the LCM of 320. 2, 160, 2, 80, 2, 40, 2, 20, 2, 10, 2, 5. 3 divided by 2 raised to power 6. We have got 6 times 2 and 1 is 5. The main procedure is that you have to make equal numbers of 2 and 5. 2 is 6 times and 5 is only 1 time. So therefore, multiply 5 raised to power 5 at the numerator and also at the denominator and also at the numerator. Now you can see 5 is also 6 times. Therefore, I am multiplying 3 multiply 5 raised to power 5 divided by 2 raised to power 6 multiply 5 raised to power 6. 3 multiply 5 raised to power 5. This is 10 raised to power 6. By multiplying these numbers, you will got 9375. 6 times 0, and by applying decimal you will get 0.00937. Now see this sum. 6 by 15. Clearly you can see 6 divided by 3 multiplied 5. Here is 3. So most of the students write this number as non-terminating. But this number is terminating. As I have told you in this sum, firstly cut these numbers. 3 is to 2, 3 is to 5. Now it becomes 2 by 5. 5. Therefore, this number is terminating. This is a tricky one sum in the 10 parts. Now, by changing it into decimal for questions, 5 multiplied by 2, because 5 2 is 10, and multiplied by 2 also here, 4 by 10, then it will become 0.4. Hope you will like these sums and try to solve the other sums also. और लास्ट में सिर्फ यही बात कहना चाहूंगा मैं कि इस चैप्टर को मैंने अच्छे से आपको समझा दिया है। लॉकडाउन का समय है, बोर्ड की क्लास है, तो उम्मीद करता हूं कि आप इसे अच्छे से समझेंगे और आपकी जो भी क्वेरीज है मेरे चैनल के कमेंट बॉक्स में आप नीचे कमेंट करिए और सबसे मेन बात, चैनल को सब्सक्राइब जरूर करिए और बेल आइकन को प्रेस करें।